Alright, so here we have the 2009 BC3 question. For part A, we're going to start off by finding the maximum vertical distance from the water surface to the diver's shoulders. So since we're going to be looking at the y, you want to look at this equation right here. And first I looked at the top of the highest point where the diver was jumping, and that is where the dy is equal to 0. If you look at the very tip top point, the maximum vertical distance right there from the water is where the dy, the change in y, is equal to 0. He's only moving in x. So what I did was I first set the dy dt equation equal to 0 to find the time when the change in y is equal to 0. So you get 3.6 minus 9.8t equals 0. So you can solve that yourself. And I get 0.3673 is equal to the time where that's the time when the dy is equal to 0, and that's the very top point. So now that we know that, you can find the maximum vertical distance from time 0 to 0.367 of this equation right here of dy with respect to dt. And so I would punch in, if you guys don't already have these equations punched into your calculator, go ahead and do so and take the integral of this equation from 0 to 0.367. Okay, so if you properly integrated, you should have got this to equal 0.6612. And that is the change from 0, that is the distance from 0 to 0.367. That's the difference in height. Now, if you notice that at time 0, you have the position is the y position is equal to 11.4, and now the new position is 0.6612 above that. So you just add 0.6612 to that, and you get 12.06. So that's what I got for part A. 12.06 is the maximum vertical distance from the water surface to the diver's shoulders. I'm going to go ahead and go to a new slide. Okay, so for part B, we're going to find the time that it takes for the diver's shoulders to hit the water. For this, you want to set the y equal to 0, because that's when the height is 0 when the diver's shoulders hit the water. So you have your dy dt again is equal to 3.6 minus 9.8t. So you're going to need to integrate that. And so what I did was I got 3.6t after So that's what I got once I integrated. And we're given that at time equals 0, the y value is equal to 11.4. So I'm going to set this equation equal to 11.4, and plug in 0 every time I see a t. So I get 3.6 times 0 minus 9.8 times 0 squared over 2 plus c is equal to 11.4. So I get my c is equal to 11.4. And now that I have that, I have this whole equation now, and I'm going to set that equal to 0 to find what time it takes until the diver reaches a point where the y value is 0. So I'm going to go ahead, 3.6 t minus 9.8 t squared plus 11.4 equals 0. And I would go ahead, and the best way to do that I would do that is plug it into your calculator and find the y values, or find the zeros. So go ahead and do that. So you should have got 2 zeros. One is negative, and you can't have a negative time. So the positive time that you should have got is equal to 1.2778. And that is your answer. So I'm looking at the answer, and that is not the answer. So I messed up. I forgot to divide this by 2. And when you integrate that, you end up with a little different answer. So once I divide by 2, I'm going to try that again. Sorry guys. And now I got the right answer, 1.936. And there's other ways to do this, but I thought this is the easiest for me. So there you go. There's part B. I'm going to go on to part C. So here we go. Find the total distance traveled by this diver's shoulders from the time she leaps from the platform until the time her shoulders enter the water. So now that we know the time that it takes until the diver hits the water, well, we're going to use that to find the distance, the total distance that he traveled. So the distance equation is going to be from the integral from time 0 to, we're going to say, the time that it took him to hit the water, which is 1.936, which was the time that it took him to hit the water. And then we're going to take the square root of dx dt squared, which is your 0.8 or y1, and then plus dy squared. So there you go. You guys can punch that into your calculator and find it out. So when you integrate this, you should get 12.942. Once you get this, this is the total. This is the total distance that he traveled altogether. So I'm going to go on to part D, the trickiest one. So here we go. So what I did was I quickly drew out what you guys are looking at. So the angle is the theta. That's your dy and your dx. And you're trying to find the angle between 0 and pi over 2. And so I'm going to go ahead and show you guys how to do that. You guys learned in class how, in order to find out this theta, you have tangent of theta is equal to dy dt over dx dt. So if you plug that into your calculator, you can find the theta. You can go ahead and find theta by plugging that into your calculator. And so I'll let you guys do that. So you guys should have got 1.4 1.518. Now, if you go to negative, I was talking to it with Mr. Hawks, and he gave it to me like this. This is the angle at which he's diving down, and this angle right here is going to be the same angle, but this is a negative angle, and this one's going to be positive. So, basically they're the same, but that's the reason why. So 1.518 is the angle. So there you go. Done with BC 2009-3.